Hi, in this video we're going to be talking about tangent lines in circles. So some vocabulary to get us started off. A circle always has a singular point, which is the center of that circle. And that center of the circle is the same distance to every point on the outside. And that distance is the radius of the circle. We then, from that circle, can make a tangent line. So this right here is tangent to the circle because it only touches the circle at a single point. That single point where it touches is the point of tangency. Gen-C. Great. So those are some of the vocabs that we're going to be taking a look at. Our first theorem of this lesson is that if we've got a tangent line at some point, then that tangent line is perpendicular to the radius of our circle. So this red line and this blue line are perpendicular with each other. So that lets us do some cool, like right triangle, solvies things. So we've got EC is tangent to this circle at E. So I know that this thing is tangent to our circle, meaning this has got to be a 90-degree angle. If that is a 90-degree angle, then I've got a cool little right triangle hanging around right here. So then I'll know that I've got 180 degrees. That should equal my right angle that I got, the 90 plus 49 degrees plus whatever x is. So that's just going to be a quick little solve. I subtract 90 from both sides. So I got 90 equals 49 plus x. Subtract that 49 from both sides, and 41 degrees equals x. In this next example, I'm going to use another thing that we can do with right angles and right triangles. If I've got a tangent line there, I know that is going to be perpendicular to this radius. And we've got another radius right here. We could say, hey, this is a little right triangle. If this is a right triangle, this is going to be my hypotenuse right here. So that x plus 9 squared, that hypotenuse squared, should equal my two legs being squared. So x squared plus 13 squared. So I can square these two just fine, but this one is going to require a little bit of extra work. I'm going to need to FOIL these two, this thingy. So that's an x plus 9 times an x plus 9. Is going to equal x squared plus 13 squared. So I got to multiply my firsts together. So x times x, I got to multiply x by both of these things. So x squared, x times 9 is going to be 9x. 9 times x, that's another 9x. And 9 times 9, that's 81. Equals x squared. And I'm going to take care of this 13 squared. That is 169. Then I can do some solving. I can subtract an x squared from both sides. 9x plus 9x, that's going to be 18x plus 81 equals 169. Okay, I'm going to finish my solve over here. I got to subtract 81 from both sides. So I got 18x equals 88. Divide both sides by 18. That doesn't divide super nice, so I'm just going to try to clean it up a little bit. I can divide top and bottom by, well, we could divide top and bottom by 2, so that's going to be 44 over 9. I think that's about as simple as that one is going to get. So that's my answer. Now, this theorem is a biconditional. So if we can show things are perpendicular, then we know that that line has to be tangent. So if we use that same idea of the Pythagorean theorem on this problem, if I get a good Pythagorean theorem setup, and then this thing is going to be a right angle. But I don't know if it is or not. It needs to work in the Pythagorean theorem to work. So I need to see if 7 squared plus 24 squared equals 25 squared. If it is, then this side is going to be tangent. If it's not, then it's not going to be tangent. So let's see, that's going to be 49 plus 576 equals 625. 576 plus 49 is going to be 625. Hey, that worked. So since this is a right angle, then we are able to say, yup, this thing SA is tangent to our circle, to circle P. Let's try that one more time in this diagram. So I've got this side 3 that I'm hoping is tangent, but I don't quite know if it is. So I want to know if 3 squared is going to be the same as, let's see, here's our other leg that I'm hoping to make a right angle with. So plus 1.25 squared. I want to see if that equals this red line over here. 3.25 squared. So I just got to see if all that stuff works out. Well, 3 squared, that's 9. 1.25 squared is 1.5625. And then I just got to do 3.25 squared, typing that into my calculator, and I get 10.5625. Hey, if I add those two together, this is going to be 10.5625. That's going to be equal to another 10.5625. So, yes, CA is tangent to circle R because triangle RCA is a right triangle by the Pythagorean can't spell Pythagorean theorem. That's it. In this example, I want to solve for the distance between these two centers from A to D, and I want to figure out what this side is right here. I'm probably going to do some right triangle stuff. So I know this is point 2, and this is tangent and parallel. So this little segment right here should also be 0.2. I know the whole thing is 0.8. So that must mean this little segment right here is 0.6. Also, because these two lines are parallel, this is sort of forming a parallelogram, our opposite sides have to be congruent, just like these two opposite sides have to be congruent. So I know this side is 2.4. Using that, I can make a nice right triangle here and say that 2.4 squared should equal 2.4 plus 0.6 squared. That should equal whatever x squared is. So that's just something I got to solve. So 2.4 squared I know is 5.76. Plus 0.6 squared, I know is 3.6, and that equals x squared. And then I got to add these two together, so that's 8. 9.36 equals x squared. I would then square root both sides so I can get that x by itself. So x is our distance between those two. So I just need to do the square root of 9.36 on my calculator. And so x is approximately 3.0594 for that distance right there. Great. In this example where I determine the distance between the centers, I know CD is tangent to these two, so I know I've got a right angle right here, and I've got a right angle right here. But see how this is 26 and this is 30? I'm not able to make that transfer from 81 since these two measurements are not the same. Uh, just like I could up on this one. So since these are not the same, I can't say that these two are going to be the same. What I can do is I can solve the missing piece of this triangle here and use whatever this is to try to go after my end goal, which is what this x equals. So first thing I'm going to solve for is that little question mark. So that means 26 squared plus 81 squared is going to equal whatever that question mark squared. These are my two legs, and that's my hypotenuse. So that's just a matter of typing it into my calculator. I got 26 times 26. That's 676 plus 81 times 81. That's 6,561 equals my question mark squared. And 676 plus 6561. So my question mark squared is 7237. That is my question mark squared. Now, keep in mind, I'm about to square that thing in order to find x. So I'm actually going to keep it like that just to kind of like save myself a little bit of trouble. Because if I want to find x, I know that it is going to be x squared plus 30 squared is going to be question mark squared. Because the question mark is the hypotenuse of this right triangle. So I'm just going to keep it that 7,237. Then I'm just able to be a little bit more accurate. 30 squared, that's 900 plus x squared. And then I'm going to subtract 900 from both sides. So x squared equals, let's see, that is going to be 6,337. So x equals the square root of 6,337. They wanted us to round that to the nearest hundredth. So the square root of 6,337 is 7, 9 point, and to the hundredths, that's going to be 6. I'm going to round it down to 60. You could round it up to 61, depending upon how you want to interpret 5. Some people round the 5s up, some people round the 5s down. All right, another different cool thing about tangents is that if you've got two lines that are tangent, so this line is tangent and this line is tangent, then what happens is where those two meet and after they touch, these two segments have to be congruent. So this quadrilateral circumscribes a circle. So that circumscribe means that it is tangent on all sides. So I know this is a point of tangency, this is a point of tangency, and this is a point of tangency. And what that tells me is that just by that theorem, that this line and this line have to be the same. So 4.43. We can also say that right here, this line and this line, because these are 2 points of tangency that meet out here, also have to be congruent. So this is 2.31. We can do that again over here. Okay, so this and this, those are both the same, so that is 1.4. And then we've got a final one over here. This 3.6 is going to be the same as this right over here, 3.6. So all I need to do to find the perimeter is find the sum of all of those sides. So that's 3.6 plus 3.6 plus two 4.3s, so plus 4.43 plus 4.43 plus two of our 2.31s, 2.31 plus 2.31, and then a couple 1.4s. I'm running out of space over here. I'll put them at the beginning. Doesn't matter what order you add them up in. There we go. Okay, well, let's see. That is 2.8. The 3.6s make 7.2. The 4.43s make 8.83s. 8.6s, excuse me. And then the 2.31s, they make, if I grab the right color, plus 4.62. So I just got to add all of those up. And so after adding those all up, I got 23.48 for that perimeter. And that's it for the video. So two things to remember is that if you've got two tangent lines that meet on the outside, they are congruent, as well as if you've got a line that is tangent, it's perpendicular. And if you've got a perpendicular line to a circle's radius, then you know it is tangent. Thanks for watching. Bye-bye.